Okay, well this will have to be recorded. I'm not repeating this. All right, so if we have this phospholipid bilayer and we've got the proteins, one of the proteins that we'll have is a channel protein. This would be there for something that would be water soluble because fats and water don't mix. All right, so that's why something that's water soluble needs to have the channel. Now, there are other proteins that exist in this lipid membrane. Not just channel, okay? Which, don't get me wrong, channels are good, okay? But there are things that the cell is going to need to make sure that it either keeps out or lets it in. So that's why it's going to be termed selectively permeable. For the channel proteins that just simply let stuff pass back and forth, these are usually referred to as leak proteins. Now, one of the things that you're going to find, when we take in our foodstuffs, okay, like who had breakfast this morning? Breakfast is the most important meal of the day, okay? If nothing else, get you some little oatmeal bars or something. You gotta have your fuel for your brain to work, okay? It is the most important meal of the day. So when I asked that on Tuesday, I want to see everybody's hand go. Now, okay, so we take in our foodstuffs, which means we take in our sugars, we take in our fats, we take in all the proteins, we take in these nutrients. Our body begins to break them down. As they're broken down, they make their way into the bloodstream. They travel through the bloodstream, make their way to the cells, so the cells can use it. Does that make sense? So, this means we've got the sugars, we've got the fats, we've got the proteins. Proteins will be broken down into their amino acids. But let me think of something. Does anything else come with our foods? Vitamins? Minerals? Let me think here for a second. If we look at these vitamins and minerals and the salts, what becomes important when we take in salts, for example? What do you think of when you hear salt? Sodium what?
Sodium, potassium, pump.
All right, you're thinking the pump, but let's think about our food source that comes in. Sodium what? Sodium chloride. All right, when we think of our normal, everyday table salt, is that not what we think about? Wait a minute. Is that all my table salt is? Used to be. She said it was iodized, okay? But now with all these different, because see, I'm so old, when I grew up, the only salt I knew of was the Morton salt, the one in the blue container, had the little flip little lid. Used to love to open the little flip little lid, you know. And then we had those, y'all probably don't even know what Tupperware is, but we had like the Tupperware salt and pepper shakers, okay? You'd fill up the little Tupperware shaker, you know, and you felt so good, and you know, and you'd be like, oh, that's so cool, little girl walking with a little umbrella, you know, on the Morton thing. And then it had iodized. Any of y'all know what I'm talking about?
Yes.
But for the most part now, when you go to the store, you buy salt. What do you get? You're buying, oh, the Mediterranean sea salt, or the Himalayan sea salt, or whatever, okay? And if you read that label, you will see on that label, this product is not a source of iodine. So, you got to go back to the little blue Morton thing that went in a store, usually all the way down on the bottom shelf, 1 or 2 little cans of it there, and that's it, to get your iodine. Which is important. But see, here's the thing. We've messed with our food so much, we're supposedly getting it from our food. Don't even get me started on that topic. Okay, so when we look at the salts that we take in, we're going to be getting sodium, potassium, hopefully some magnesium, zinc, so forth. So usually when we take in salt, it's covering a lot of these trace elements that we're going to need. So what happens, because the cell membrane is selectively permeable, we end up with a lot of the salts outside the cell. All right? Now, in your part 1, and you began to talk about muscle contraction, nerve conduction, what are the 2 that were the most important?
With calcium for the muscle.
Well, calcium we're going to need for muscle and the nerves, the heart, that sort of thing. But wait a minute. When y'all talked about it in part 1, didn't y'all talk about it in relationship to the movement of these ions across the cell membrane? Please tell me that you did, because that is the most important concept you need to know. Okay, when you look at the cell, the concentration of these ions, sodiums, are high outside of that cell membrane, okay? Down here, inside the cell, we got potassium. But see, here's the thing. With potassium can simply just kind of go back and forth, back and forth, back and forth. Sodium doesn't do that quite as easily. All right? Now, what that does, it sets up a situation where the outside of the cell is positive, but the inside of the cell is negative. Is everybody with me? Okay? Now, what do we know about opposites? Opposites what? Opposites attract. Only in chemistry. Okay? But what we have now, we have a situation where it's more positive on the outside of the cell, more negative on the inside. But that's good. Why? To help what? To help, why, well, not really, but sort of. It's kind of weird, okay? But why would we need those positives to move across the membrane? ATP uses the glucose and the oxygen. in the mitochondria to make the ATP. But do we need that ATP for this also at some point? Yes. Okay, so y'all really were not taught this. Okay, I'm shocked because this is the most important concept.
What about the electrogradient?
Okay, what about it?
Like it has to produce an electrical charge.
Why?
Because the electrical charge is what gives it energy.
Not what gives it energy, but makes it work. Now I'm gonna kind of break that down for you, okay? Because I'm finding out that's something I got to teach to you too, okay? Now, when you look at this, here's the reason why knowing about these ions is so important. Think about which ions we're looking at. Sodium, potassium, chlorine. Where in a medical setting are you going to encounter this? Okay, we're going to encounter it with IVs.
Electrolyte imbalance.
Because I might have an electrolyte imbalance. Why?
But why you might have electrolyte imbalance?
Yeah, why might you have that?
Dehydration.
Dehydration.
Fluid overload.
Fluid overload.
Infection.
Infection. How about maybe, let me think about this for a second. The person comes in and they might be catatonic. The person might have a heartbeat that's through the roof. Person might have a heartbeat that's barely going. Do you realize that every single one of these comes down to these ions? This is why I'm amazed they didn't teach this in part 1. You look at the patient comes in exhibiting some type of symptoms. Okay? What's the first thing usually gets done? Huh?
Vital signs. Vital signs.
And then blood work. They come back with the blood work. You got that piece of paper in front of you. And you're looking at it. It's going potassium high, potassium low, calcium high, calcium low, sodium high, sodium low. Every single one of them has a consequence in the body. This is what you've got to know. Because it's going to affect every system in the body. It's going to affect the muscles. It's going to affect the nerves. Now, when I say muscle, what pops into your head? Huh? Okay, cardiac. Is that the only type we have? What other types of muscle do we have?
Skeletal.
We got skeletal, cardiac, huh? Smooth. Now we got our nerve conduction. Every single bit of it functioning on this. Now do you understand why I need you to know this? It's everything. Everything. Any questions so far? Okay, so what's going to happen